Alright, Professor Garb here, and we're beginning lesson 5.1 here. I've written down the problems that appear in Hawks, is that way we can just see them. And in class we'll go over the PowerPoints together and some other activities. So here's 5.1, and the function is f of x equals 5 over 2 to the x, and they ask you which one of these functions is a graph of it. This is called an exponential function. Okay, that means that the variable has an exponent in it, so 5/2 is over 1. So as x gets bigger, what we care about is the end behavior, right? So if x is 1, it's 5 over 2. If x is 2, it's going to get even bigger and bigger. So as time goes on, as I move to the right, the graph should get higher to the right. So as x gets bigger, y should get bigger also. So therefore, a is automatically out. Okay? Go on, I'm going to get rid of that one. Now let's say x is 1. Well, if x is 1, right? If x is 1, then this is going to be 5/2. Or x is 0, y is 1. So if x is 0, y is 1. Well, if x is 0, y is -1. That's definitely wrong down here. That can't be right. Okay? Because when x is 0, it's a negative value. So it's really in between these two guys. Okay? C and B. Well, when x is 0, y should be 1. When x is 1, y is... This one doesn't seem to grow fast enough. So, because this one's practically right here, like right on the x-axis. I know these graphs are not precise, but as it gets, see this one seems to grow faster when x is 0, y is 1. So I'm going with B right here. It's gonna be the best graph. So this one doesn't seem to grow very fast. You can't see the detail, but if you put a point in there, like x equals 1, 1 and 5/2, it's right here. This one is 1, 5/2 will be like way above the curve. You can't really see that because this is inexact drawings, but there's number 1. Okay. Number 2, they have the following graph. They say f of x is equal to 9 over 4 to the x minus 2. Well, again, that is an increasing function, right? So as x gets bigger here, right? So the exponential function, x is an exponent. So if x is as x gets bigger, like to the 10th power, then something over 1, like 9 over 4 is something over 1 raised to that power is going to get bigger and bigger and bigger. So therefore, it cannot be this function here. That one's definitely wrong. All right. Let's put a number here to make it interesting. So if x is equal to 2, right? If x is equal to 2, that makes that 9/4 to the 0 power. So that makes that 1. So when x is 2, y is 1. That's why I mark these off with these little tick marks here. So you'll see that 2 comma 1, right? Yeah, so this one's way above the curve. Okay, they're all increasing functions. When x is 2, y would be a little over 2. So when x is 2, y is to be a little over 2. So when x is 2, y is 1. So that's wrong because it didn't grow fast enough. When x is 2, y is 1, that's too high. Okay, when x is 2, y is 1. So this graph's above. So that one's wrong. So it's definitely going to be this one here. So what you're doing is you're plugging in points, and these are reliable. I put those out there to show you what they were to make it accurate. All right, that's the information that you needed. So this one's going to grow, but this one grows a little bit slower than these do too, but it does work. When x equals 2, y is 1 right there, so that matches exactly. What else could you tell? Well, when x is 0, that's way too high. When x is 0, that's way too low. So that one makes sense. It's a little bit above there. Okay, x is 0. So when x is 0, this is going to be negative powers, 9 over 4 to the negative power. So that's going to be a small positive number. So you know this one's definitely not right because it's too big. Number 3. Number 3 says 16 to the x minus 6. So what we do here is we're trying to solve for x by adding 64 to both sides. Okay, so we add 64 to both sides. Then when we do that, well, we know that 16 to some power has got to equal 64. We don't know logarithms yet, so we have to solve this with the information that we know. So what we're going to do is we know that 4 to the 3rd power equals 64. So can we write 16 as a power of 4? And yes, we can. So we could say, well, 4 to the 2nd power, make that equal to 16. See, 16 is equal to 4 to the 2nd power. 4 to the 2nd power to something else is equal to 64. Well, we need to make that a 3. Well, using the power rule, we have to multiply, so it's going to be 2 times something equals 3 to make that work. So therefore, that something has got to be 3 over 2. So therefore, the answer is 3 halves. So therefore, 16 to the 3 halves power equals 64. And that makes sense because 3 halves is between 1 and 2. 16 to the first power is 16. 16 to the second power is 256. So 64 is in between 16 and 256. So that does make sense. And number 4 right here, if you take a look, this is a number that's greater than 1. And we have to ask ourselves, what happens? Is it an increasing function or a decreasing function? Well, as x gets bigger, this is going to become a negative exponent. So this whole thing is going to get smaller, okay, as x gets bigger. So let's say x is 5, right? So it's going to be 17 over 4 to the negative third power. Well, this whole thing is going to get smaller, but then it's 1 over that. So, and the whole thing altogether is going to be an increasing function because it's in the denominator, okay? So let's figure out which answer makes sense here. I think it makes sense to plug in 2, plug in 2. So if we plug in 2, right? If we plug in 2, this is going to be 1 over 17 to the 4th to the 0 power. So it's going to be 1 over 1. So when x is 2, y has got to equal 1. Well, if we take a look here, this one's not going to work. At 2 at 1, it's not going to work. It's right there, so it's below the curve. At 2 at 1, no, that's below the curve. So it's got to be this guy right here. This is 2, this is 2 comma 1 right there, so this is the right one. Now when you look at these problems inside Hawks, you'll see that there'll be a grid there, but I just want to give you the strategy is to plug in a 0 and see what happens there, and then you can tell whether it's an increasing function or decreasing. So this is decreasing, but it's 1 over, so it becomes increasing. Alright, here's number 5. Now the key with trying to solve this problem is to try to get the same base, because if you get the same base, then you could set the exponents equal to each other and then solve. So that's the idea. So since 1/3 is related to 1/9, this one's already 1/3, so I'm going to leave that way. So I have 1/3 to the 3x plus 6. I leave that the way it is, and then over here I'm going to change 1/9 to 1/3 to the second power, because 1/3 times 1/3 equals 1/9. So that's 1/9, but then that is to the 4th power, because it's 1/9 to the 4th power. So therefore, we now have 1/3 and 1/3. So we have 1/3 to the 3x plus 6, okay, equals, now over here, we're going to have 1/3, now it's going to be to the 8th. So therefore, 3x plus 6 equals 8, all right? And then 3x is equal to 2, and therefore x is equal to 2/3. All right, moving on to number 6. Now in this case, again, we want to get the same base. So here, we're going to try to get 5 being the same base, okay? So over here, I'm going to have 5 to 3x minus 7. But this is 1 over 25 is actually equal to 5 to the negative second. So we're going to rewrite that as 5 to the negative second. So again, we're trying to get the same base here so we can set the exponents equal to each other. So we have 3x minus 7 is equal to negative 2. So we have 3x is equal to 5. So we have x is equal to 5/3. That's our answer for that one. Moving on down here. Now, what do these guys have in common? Well, you don't want to divide the 8 into the 16, although it's very tempting. We have to get the same base. So you might look here, and we're going to say, okay, that's going to be 2 to the 4th power to the negative. They're both base 2. And this is going to equal to 2 to the 3rd power. So now we can rewrite this. We have to multiply these exponents right here. So going up here, we're going to have 2 to the negative 4x is equal to 2 to the 3rd power. Okay? 2 to the negative 4x is equal to 2 to the 3rd power. And then we could equate these exponents to each other. So we're going to have negative 4x equals 3. And we have x is equal to 3/4, and make that negative. So negative 3/4. Here's our final answer for that one. Moving down to number 8, if you could see it. Right there, you have 1,000 to the negative x power equals 10 to the 8x minus 14. So you probably notice we're going to have base 10 here. So we have 10 to the 3rd power raised to the negative x. And over here you're going to have 10 to the 8x minus 14. Alright, so then you have both to the 10, both with base 10. So we're going to say, okay, that's equal to 10 to the negative 3x is equal to 10 to the 8x minus 14. And therefore, we could equate those terms now. So we're going to have negative 3x is equal to 8x minus 14. And then we solve for x. You can do that either way. So I'm subtract 8x from both sides. You get negative 11x, okay, is equal to negative 14. We divide by negative 11 on both sides, okay, and we're going to get x is equal to 14 over 11. And that is the correct answer there. For number 9, we're working down to number 9 here. Making to figure out what to do here. So a clever thing to do here, to look at these 4 choices, you got to figure out which graph makes the most sense. Try like putting in that function. We're looking at this one right here. All right, we're saying, okay, well, what if we put in 0 there? If I put in 0 for x, what would happen? That's the easiest thing to do, is try and intercept. Well, that would make this whole thing equal to 1 in the denominator, right? So that would make it 1 over 1 minus 1. So that would be 0. So therefore, 0 makes 0. So which one of these has 0, 0? Well, that one doesn't. That one doesn't. This one does. And that one doesn't. So therefore, that must be my answer right there. Now, for number 10, all right, number 10 is g of x equal to 1/4 of 2 minus x. We have to find out which graph works for this one. Now, for this one, I'm tempted to look at that and say, okay, let's plug in a 2 to see what happens. Well, if I plug in a 2, I'm going to get 1/4 to the 0 power. And we know that 1/4 to the 0 power is going to equal 1. So we know when we put in a 2, we should get a 1. We look down here and say, which one of those works? Well, this one clearly doesn't. Well, first of all, before we do this, we should say, as x gets bigger, okay, we're going to have 1/4 to a really negative exponent, right? So a really negative exponent, like closer, negative like 10 or something like that. Something that's going to be really big, negative 10, negative 100, whatever. So as this gets bigger and bigger and bigger, this means it's going to be, this is going to be 1/4 to a really negative exponent, which means it's going to be 4 to a really positive exponent, which means it's going to increase. So we know we have an increasing function, which means this one's definitely wrong. And also, what we're looking for, 2 comma 1 should work, but this one's definitely wrong. 2 comma 1, no, that's definitely not going to work on this one because it's right on the x-axis, so that one's definitely wrong. And this one here, 2 comma 1 is above, so this one's not going to work either. So the one that works clearly from looking at the picture, and if you saw this on Hawks, you can see it's exactly 2 comma 1. So we're going to say that one's going to work right there. There you go.